Welcome to Saxon Math Course 3, Lesson 96, Geometric Measurements with Radicals. Now, before we begin the lesson, there is some background we need to go over. How we multiply radicals and how we add radicals. Because today we're going to be finding areas and perimeters of shapes that have sides, which are radicals. Now, to multiply radicals, we're going to use the product property of radicals to multiply. Now remember that in variable form, the product property of radicals is the square root of a plus the square root of b is equal to the square root of a times b. Or, with numbers, the square root of 2 times the square root of 8 is equal to the square root of 2 times 8, which would be 16. Once we've done the multiplication, we simplify. The square root of 16, that's 4. If we had a compound number that was not a perfect square, we would simplify to the least radical. We would simplify to have the smallest number possible in the radical, with every perfect square that's inside of it taken out and as a coefficient. In order to add radicals, there are two criteria, meaning two steps we need to make sure are true before we add any radicals. They have to be the same kind of radical. So if we have a square root and a square root, you're good. If you've got a square root and a cubed root, you can't add those. So if they're the same kind of radical, you can add them. They also have to have the same radicand, which remember is the number in the radical. So if I have the square root of 2 plus the square root of 2, I'm good. If I have the square root of 2 plus the square root of 3, not so good. Not the same number, you can't add them. Then we're going to just treat the radical like it's a variable, and we're going to combine like terms. Now, the square root of 2 plus the square root of 2 plus the square root of 2 plus the square root of 2, all of these have a coefficient, a number in front of them, of 1. There are 1 of them in each of these instances. So we would do 1 plus 1 plus 1 plus 1, which is 4, and we would have 4 root 2. Just combining like terms. There are 4 root 2's here, so we say it's 4 root 2. That's our background information. I'm going to leave this on the screen for just a second. Alright, we're going to move on to example 1. Now, example 1 says find the area and the perimeter of this rectangle. Now, in order to do that, first I'm going to need to find the length and the width. Now, if we look at this rectangle here, each of its sides forms an isosceles right triangle of 2 and 2 and of 3 and 3. Now, if this is the hypotenuse of a 3, 3, 45, 45, 90 right triangle, this side here, this longest side, has to be 3 root 2. Similarly, if this is a 2 and 2, 45, 45, 90 right triangle, this has to be 2 root 2. Our next step is to put these values over here. Our length is 3 root 2. Our width is 2 root 2. Now, as we're moving forward, we need to first find the perimeter. Now, the perimeter I've written here says length plus width plus length plus width. So we're going to have our length, 3 root 2, plus our width, 2 root 2, plus our length, 3 root 2, plus our width, 2 root 2. Now, if we had different radicals, we would combine them like this. We would say our lengths are 3 root 2 plus 3 root 2, and our widths are 2 root 2 and 2 root 2. And that would give us 3 and 3 make 6 root 2. 2 and 4 make 4 root 2. So our answer, 6 and 4, is 10 root 2. Now, notice we are able to add all of these because we have the same square root on all of these. We all have a root 2. Now, the area is a little bit simpler. It's just the length times the width. So we've got 3 root 2 and 2 root 2. Now, this is going to be a little bit trickier than the example in the background. 3 root 2 times 2 root 2. These numbers already have a coefficient, so we're going to rewrite this as 3 times 2 times root 2 times root 2. Now 3 times 2 is 6. Root 2 times square root of 2 is square root of 4, which is 2. 6 times 2 is 12. So for this rectangle up here, the perimeter would be 10 root 2 units, and the area would be 12 units squared. That's example 1. So we can see here, when we're finding perimeter and area, we're just using the same formulas that we've been using this entire time, except for now, there's radicals involved, so we have to follow the rules for adding and multiplying radicals. So let's go over to example 2. Example 2 has a triangle. Now, example 2a says find the length of the hypotenuse. Now, we have our two legs, 1 and root 3, so we can use the Pythagorean theorem because it's a right triangle. Remember, the length of the hypotenuse, c, is equal to the leg squared plus the leg squared. So c squared equals a squared plus b squared, or c squared equals 1 squared plus root 3 squared. Now 1 times 1 is 1. Root 3 times root 3 is going to be root 9, or 3. 1 plus 3 is 4. And I'm going to need to take the square root of both sides. Now you might think to yourself that my answer would be plus or minus 2. It won't be plus or minus 2, it's just going to be 2. And the reason for that is it's the length of a shape. Remember that lengths, dimensions of shapes, always have to be positive, so c will be 2. And then we're asked to find the perimeter. So we have our a, which we said was 1, our b, which is root 3, and our c, which is 2. Now looking at this, 1 and 2, neither of them have radicals, so we can add them. 2 plus 1 is 3. Root 3 is a radical. Are there any other radicals in this expression over here, this side of things? There's not. So we're just going to leave the root 3 right here. And we would say that this is our answer. Now, that's the end of our examples for today. We had a quick 2-example lesson. There's going to be another video on the practice set and on the starred problems attached to this same resource. So make sure you watch all 3 videos. Stay safe, wash your hands, and do your math homework.